Hey guys, welcome to Empty Stacks and you are watching LeetCode series of problem solving using Java, and today we are going to look at reshape matrix. To solve this question, it is good to have knowledge on arrays and matrix. The difficulty level is easy and the question was asked in interviews for companies like Facebook, Bloomberg, MathWorks, etc. Okay, let's jump into the question. We are given an m cross n matrix and two integers r and c. We need to reshape the input matrix into another matrix of dimension r cross c. If for some reason reshape is not possible, we need to simply return the original matrix. Let's take some example. Say our input matrix is of size 2 cross 3 and value of r and c is 3 and 2. So we need to return a 3 cross 2 matrix with elements in the same order that of the original matrix. So the result matrix would look something like this. But if value of r and c were 4 and 2, then it is not possible to reshape the matrix, as original matrix has 6 elements but result array requires 4 into 2, 8 elements. So in this case, we can simply return the original matrix. Okay, now let's try to build an approach. We can start with the same example. We saw that if the number of elements are not same, the reshape is not possible. So we can say if m cross n is not same as r cross c, we return the original matrix. So if input given to us is a 2D array called matrix and two integers are r and c, we firstly find m and n, where m is equal to matrix.length, that would give us number of rows, and n will be equal to matrix 0.length, that would give us number of columns. Next we put a if condition to check if product is not equal, we return the input matrix itself. Let's move further. Say if the product is same. Now we need to return a new result array of size r cross c after filling it with the elements from the input array. So we can add next part to our pseudocode where we initialize the result array of size r cross c, then we would do some operation to fill this result array and finally we return it. Now let's see how we can fill the result array using the original matrix. Let's take another example. Say the input matrix is of size 2 cross 6 and is filled with values from 0 to 11 in the same order. And value of r and c given to us is 1 and 12, meaning there is only one row and 12 columns. We see that the products are same, so we can try to fill in this matrix. We know that we have to keep the same traversal order while filling in this matrix, so values would be filled with starting from 0 at the first index to value 11 at the last. Let's take another value of r and c, say 6 and 2. Again, products are equal, so we can fill in the values from the input array. If we keep the order same, in the first row we will have 0 and 1, second row will have 2 and 3, and so on. We are getting some idea now on how to fill the values, so let's try to form some algo. First thing, we need to iterate over each element, so total iteration would be m cross n or r cross c. So we can write a for loop where I equal to 0, I less than r cross c, and in every iteration I is increased by 1. Now secondly, every cell in the input matrix corresponds to some cell in the result matrix. But since we don't know yet exactly which cell from the input matrix will point to which cell in result matrix, so we can write result xy equals to matrix AB, where xy, a and b are some dummy variables whose value we don't know yet. Now we can put this loop into our main logic and we can focus on finding values of these arbitrary variables. Let's start with a and b. Here we can see a represents the row of the input matrix, so in our example its value can only be 0 or 1. Same way b represents column of the input matrix, so its value can vary from 0 to 5. Now let's see on what all things value of a and b can depend on. So for sure it can depend on the size of the input matrix, that is value of m and n, which is equal to 2 and 6 in our case. It can also depend on value of I, which can vary from 0 to m cross n, or in our case we can say from 0 to 11. Now let's try to define a and b using m and I. Let's start with the first element. For the first element, value of I will be 0, m and n are basically constant, so its value will always be 2 and 6. The first element is in the first row and the first column, so value of a and b will be 0. Next, if I is equal to 1, we are looking at the first row and the second column, so a and b will be 0 and 1. Same way for I equals to 2, a will be 0 again and b will be 2. Similarly for 3, 4 and 5. Now when I is equal to 6, a will become 1 as now we are looking at the second row, and b will become 0 as we are back on the first column. We can fill in the rest of the values in the same way, where a will remain constant on 1 and b will vary from 1 to 5. Now we need to find a relation between m and I and a and b. If you look closely, if we divide I by n, the quotient what we get is basically a and the remainder is b. For example, if you divide I equals to 8 by n, which equals to 6, you will get quotient of 1 and remainder of 2, and that is exactly the value of a and b. You can check this for any value of I. So we can write a equal to I by n and b equals to I mod n. Same way, let's try to find the value of x and y. If you notice the way a and b are representing rows and column for the input matrix, same way x and y are representing rows and column of the resultant matrix. So without giving much thought, we can say if a equals to I by n, same way x should be equal to I by c, and if b equals to I mod n, so y should be equal to I mod c. Cool. Now we have found all the values of arbitrary variables, so we can put it in our main code, and that should be it. The time complexity of this approach will be O of n, where n is the total number of elements in the input array. Okay, now let's look at the Java solution. We can start by defining m and n, where m equals to mat.length and n equals to mat0.length. Next, we check if product of m and n is same as that of r and c. If not, we can immediately return original mat from here. Next, we define our result array of size r cross c. Now we need to iterate over the input array, so we add a for loop where I equals to 0 and I is less than r into c. Now in this loop, we can simply write result I by c, I mod c equals to mat I by n, I mod n, and finally we return the result array. Let's think about the edge cases. If the length of the input matrix is 0, again reshaping is not possible. I think we are done. Let's try to run this. Perfect. See you guys in the next one.